In this video, I'm going to show you how to do a regression analysis to apply the Huber-White sandwich estimator, the HC3 estimator, for both clustered and non-clustered data. I go down here to the button for the program and click on it. When I do, a set of instructions appears in the description box. It tells you how to use the program. And then we'll be inputting information into the input values box here. Because this uses raw data, I first have to go get the raw data. So I'm going to click on Choose File here. The data are in the CRET folder, and they're in a file called Simulated2R. This information is very important because this lists the names of the variables in the file, and I'll have to refer to those names over here in the input box. And R is case sensitive, so I want to make sure I type them in exactly as they appear over here. I'm going to go ahead and put in the full folder path so that my program knows exactly where to find the data file. And now we'll input the data. Okay, so this example focuses on a program to increase parental knowledge about mental health during adolescence, and it has a treatment and a control group. The parents are run in small groups of 10 parents each, where they receive the information to increase their knowledge. The control group also receives material, but on a different topic. The post-test knowledge scores range from 0 to 100, with higher scores indicating more knowledge. So let's find the relevant variables here and then enter in the information. Okay, the outcome variable is knowledge, and that's here. And so down here in the equation, I'm going to put it as the outcome. And the predictor variable is the treatment group, which is dummy coded. Now with R, when you write out a regression equation, it uses a special format. The outcome variable is on the left. Instead of an equal sign, it has a little squiggly line like this, and then you list the predictors over here. I'm not going to put any other covariates or anything because I'm just showing you how the program works. If I had a covariate, I would put an add sign, and then I would put in the name of the covariate. And a second covariate, I'd do the same, and so on. But in this case, I only have the single predictor. We need to identify the cluster variable, and it is called group, G-R-O-U-P, and that indicates the group number that the parent participated in. So again, there were 10 parents per group in group 1 and group 2 and group 3 and so on throughout both the treatment and control groups. So the cluster variable is group. I click on register input to generate the R syntax here in the R syntax box. I copy that to the clipboard. I open up R on my computer. Up here I'm going to hit Control V to paste it, and when I paste it, it'll actually execute. The input is in red and the output is in blue, so we'll go over the output. The first thing I do is just report a traditional OLS analysis without any adjustments for clustering, and so that's presented here. Here are the regression coefficients. The intercept was 71. That's the mean knowledge for the control group, and then the program raised that knowledge on average by 10 units, and that was statistically significant. Right below it is the robust analysis that uses the Huber-White sandwich estimator, and it gives comparable information to the prior one. And in this case, the clustering made almost no difference at all. The t-ratios were very similar, the confidence intervals were very similar, and so the clustering really wasn't that critical. Okay, let me close this and come back up here. Now suppose I'm doing a study where I want to apply the Huber-White sandwich estimator, the HC3 estimator, which is better for smaller sample sizes, but I don't have a cluster design. So let me show you how I would execute that here. First, in place of a grouping variable, I would just put the ID variable, which here is ID. In essence, it treats each participant as an individual cluster with a size of 1, and it's the same as saying there are no clusters. In this particular analysis, I'll be predicting the salary of professors from 4 predictors: the time since their PhD, the number of publications they have, their biological sex, and the number of citations they have. So I'm just going to highlight these and hit Control-C to copy them. I'll paste them over here. I'll put in the plus signs in between these. That way I'm sure not to make a spelling error. And then I'll click on Register Input. That'll generate the relevant syntax. I copy that to the clipboard. I start R. I'm going to hit Control-V here to paste it, and it'll execute as it pastes. And here's the output. Again, the traditional OLS solution first with the coefficient, standard errors, and t-values. And then there's the robust analysis with corresponding coefficients, standard errors, and t-values, and the robust confidence intervals associated with those. Okay, that's it. Thanks a lot.